to the cloud. And somewhere there was a window with a presentation. Keynote. Okay. Yes, and for those of you who haven't gathered, that is definitely going to be Ben presenting. Okay, so what the heck is Fission? We've got lots of friends from the Ethereum and blockchain community dialing in today who may have different pictures of what the heck Fission is. Brooke and I, spent a lot of time in the Ethereum space and worked on things like developer tooling and developer experience. And really, we looked at it and we said, hey, we can take some of this kind of Web3 tooling and use it to solve problems that all developers have, not just those that are in Web3. So one of our taglines that we use right now is fast app publishing. So what the actual goal is to make apps simpler to build, to host, and maintain while preserving user agency and supporting makers. I like to use the word makers because while that might start with developers, we very quickly want to get to designers and users being included in that as well with some of the things that we're doing. So we have a fast and simple app publishing flow for developers today. It's been live actually since Berlin Hackathon in October and has only improved. So as a developer, you install the CLI, you get a subdomain of the form name .fission.app. Even better, Brooke wrote this really amazing thing. So it's not just like, weird app name. It's like delicious green princess is the kind of name that you can expect to get. We install a local IPFS node. We use the IPFS protocol to publish. And then on our end, our hosted service, we update the DNS link and we store files. So you don't have to constantly be running it. But if you're running the node, it is actually being served from your computer. The SDK that we bundle with the platform, we call webnative. Today, it adds login, file storage for users and apps, and basically database functionality. We'll be doing more there with things like end-to-end encryption, encryption at rest, revisions, and a bunch more built in. Soon, the thing that we're going to be working on is app cloning. So the goal of app cloning is what I said before, to empower more people from front-end devs all the way to end user customization. So imagine having an app, it's online, and almost like Tumblr or something like that, you press the clone button and you get your own copy that you can then customize and edit. And we have a couple of other ideas of how that might link into the like source app for, automatic updates or user agency actually sticking with the version that you want rather than a forced upgrade. So those are some of the ideas that we have, and this is the high level product. So our approach to tech. So we're building on IPFS, the protocol, as a key enabling technology. We have moved away from talking about it other than essentially to insiders. For a very long time, installing and running IPFS to work with our CLI was the clunkiest part of our entire system, and it was the part that people had the most problems with. So we actually automatically install and run a node, and many average Web 2 developers are not going to see anything to do with IPFS, even though the capabilities of IPFS that lets us do a bunch of the interesting things that are hard or impossible to do with a classic stack. Brooke developed the web native file system, or WinFS, to add encrypted file capabilities and permissions. As we were looking at user accounts and users owning their data, you need encryption. And so we went all the way to making a system like that. There's a bunch of other things that it layers on top of IPFS, like metadata. So very particularly, it's been designed to layer on top of IPFS and not just be sort of like an S3 style bucket. It's a file system that is attached to your browser. UCAN, which Ben will go into a lot of these things in more detail, came out of a need for decentralized auth. built on DIDs, the browser WebCrypto API, and JSON Web Tokens. So all of these things is us, and by us I mean Brooke, inventing tech to solve very particular problems as we worked our way up the stack. These last two are kind of underlying approaches that we have. So use of standards, especially portable identifiers. So IPFS itself with content addressing means that us as a host, those files aren't, or file paths aren't necessarily leaked in a way that they're totally portable between other systems, self-host your IPFS and other things like that. The same with DIDs. DIDs aren't even that widely used yet, but rather than rolling our own, we try to stick with that spec and hoping to do more with that with verifiable credentials and other things like that. The other huge thing, which is actually kind of brings us to this presentation, is that our experience in the Web3 space is embedded in this phrase: must work in all browsers, including mobile, without plugins. So our approach is that all this stuff, let's skip any part about complicated understanding or kind of new approaches to what a web app means. It's still going to be hard for users to grasp, but anybody with a web browser should be able to roll up and just use this stuff. And that's our goal, and that's our mission with this. So all of this is a front-end only stack. So, you know, some of the things that you're going to have to put together, and we're saying we want to make it so that front-end devs don't have to become full-stack devs. Fast app publishing, focus on end users, and over time, you know, we're going to measure a win by, can we have people who make apps get paid? So that's another movement that we want to be part of, is to normalize paying for apps. I know, sounds crazy. Fission Drive, a bunch of the stuff is live today. We've got a little sharp edges still, but you can go directly on the web and try a bunch of this stuff today. And we built Fission Drive as kind of a first-party app. As a mental model with a Fission account, we think of it as an open source iCloud, and that's kind of the model of apps asking permission if they can store files in your account, if you haven't actually tried it yourself before. That is it from me. Does anyone have any questions about Fission? Okay, take it away, Ben.
Thanks. Yeah, I'm not unmuted this time. Let me share my screen. So first of all, while I'm setting this up, I figure this one out. Okay, clearly I'm having more problems than I thought. Why would this not show up on? Ah, sorry, got it. Just stupid. There you go. Is this now the right size, or is it huge for people?
It's amazing. Looks good.
All right, cool. So yeah, first of all, thanks to Filecoin and also to Fission. So I'm working with Fission on this project. It's also a topic I'm super interested in. And the topic specifically is, can we actually do secure signing directly from the browser? Can we be a Web3 native in the web architecture? Right, so kicking it off maybe immediately, like what the main question we want to answer here before we get started is what makes a wallet? And then it's important to realize, like, the immediate concern will be the security of the wallet, but also the ease of use of the wallet comes to mind, right? Ledger obviously is secure and easy to use, but you need to pay for it, so it's not that great. MetaMask and Wallet Connect do a very amazing job to provide secure key management for the web, but it does interrupt your workflow when you're going through the apps. And so for DeFi apps, perhaps this might still be okay. But if we imagine that we build a Filecoin backup app, which is the end goal, or sort of the tangible goal of this project, it's hard to imagine that my mother would confirm with MetaMask to back up the photos of a holiday to Filecoin. So can we actually have a secure wallet in the browser that would feel intuitive to larger audiences? The picture is not complete. Of course, there has been the burner wallet initiative where the private key is stored directly in local storage of the browser, but it comes at a bigger security cost. It's easy to try to steal this raw key data from the memory of the browser. So it can really put a lot of value on it. Plus, it might also get erased by the browser. It's ephemeral storage. But the reason this has been created, of course, is it massively improves the onboarding for users. And so I want to say that actually ease of use is probably not the right way to think about this as, or it's not a measurable quantity that much. Thinking about a permission system is more helpful. So what is actually the permission for the wallet to sign a specific transaction? For a hardware wallet, it's obvious. As a user, you need to physically interact with the device. And as I said, MetaMask or Wallet Connect, they will prompt the user to confirm signing. But then for a burner wallet interface, for example, it's sufficient to just click the button, and the user doesn't even necessarily know that that a signature has been signed. So if we want to build a web wallet on WinFS and UCAN, I think two important security models that exist in computer systems. How do you manage permissions securely on a computer system? And so a dominant one that we definitely know is an access control list. We know this because it's the default model for databases and blockchains, where as an object, you maintain a list of all the users and what permissions they have. So you're centrally keeping a list of permissions. Quite orthogonal to that, you have an object capability model. Here, as a resource, you're going to issue a signed token, like JWT, right? JSON Web Tokens, which gives permission to whoever has this token to act on the server, for example. And so these things are always local, meaning that if Alice has permission to do some actions, she can further delegate this and possibly attenuate, but obviously she cannot give more permissions to another user. And so I want to phrase this in advance so that we have this clear in mind as we go through the rest. And so if we need to build a web wallet, we need to combine these two security models, right? If I go back one slide, blockchains are an ACL mechanism. Whomever holds the private key is the user, and that defines what you can do. Whereas if we are on the web, most of the architecture is constructed around these OCAP models. And so we need to harmonize these two or bring them together. And so there is some good news, namely since 2017, W3C, they released a recommendation for browsers to improve the crypto API that was available, but was largely ill-defined across browsers with a standardized cryptos.subtle API. And in particular, what's interesting, it allows you to generate non-exportable keys. So you can sign with them or encrypt, decrypt, but you cannot export the raw key data to the JavaScript code if you generate them as such. However, we're still not out of the woods because they support RSA for encryption and signing, AES for symmetric keys, and some elliptic curves, but those elliptic curves are not the ones that we are actually interested in when we're talking about blockchains, because those are SCCP 256K1, and in particularly also BLS 12381. So we have to do something more than this. But taking a step back, first I'd want to talk a little bit about the web native file system. So Boris mentioned this already. Fission built an end-to-end encrypted file system for that served over IPFS. And that runs entirely in your browser. And so you basically have a DNS link under boris.fission.name, which is the root of your file system. I'm massively simplifying here, by the way. There's a lot of interesting material in the white paper to read up on this. There's also an interesting talk by Brooke. But for our purposes, I'm just going to like simplify some things. Specifically, we only care here about the private app storage. So we will store application data under private apps and then the application path. But this file system is generated in the authentication page. So when you go to auth.fission.code, it generates this DID identity. So I call it ZBoris here. It's an RSA key, hence the Z, which has access to the whole file system. The cryptography of the file system is based on crypttree, and it's such that if you have access to any directory, you will have access to all of its children. So actually, when you go to some application and you authenticate with Fission, you're actually not authenticating, you're authorizing, because it will redirect you to auth.fission.code, where you are now presented with this pop-up screen that asks, like, do you want to give permissions to this application? And if you permit it, it will get the AES key of the subdirectory the application is asking for, and encrypted send it back to the original page. So actually you're getting authorization, not so much authentication. There isn't a backend server that's going to say, yes, this is Boris, we have him in our database. In addition to read access, it also gives you back this object capability, this bearer token model that, bearer token, that will say you can append to the private file system this specific directory. And it's issued from Boris to the private key or the RSA identity for that Boris generated in the Filecoin application. So that's great. What if we store private keys directly on WinFS itself? It looks good at first sight, right? On the right side, we can have read and write access to the private file system. And if we store on in a different subdirectory, private keychain, the private keys, then we can ask for explicit permissions from the authorization page to get read access to the private key that's stored in the file system. I want to have a quick word here also on like account recovery. So if you would go down this path, it's nice because if you can recover the file system, you've recovered all your private keys. So you would have one recovery for all applications and all private keys therein. But of course, it's not that easy because that's the whole point. Private keys don't work this way. We can't just say in a bearer token, hey, you have 10 minutes permission to sign with this key and don't spend more than this amount of money. And please also don't like, I don't know, vote me out of my own data or money or whatever, right? Like that's the whole conflict. You can't specify this in a bearer token or a UCAN. Sorry, I forgot my little introduction. Like the bird here is the wonderful mascot for the UCAN 0.5 specification, which you should go read.
We'll have links for all this stuff. This is the
yeah,
UCAN toucan balancing macaroons on their bill because it's inspired by some of the Google macaroon stuff.
Yeah.
It's white papers all the way down.
On SPKI. So it's local, right? So you can attenuate and delegate permissions further. Yeah, that wasn't entirely obvious why this bird appeared. Apologies for that. But there's two problems now, right? So great. So it's not an ACL model. Filecoin blockchain will just still accept whatever transaction is validly signed, and the application, as soon as it has read access to the key, it can sign whatever it wants. That's one point. And the second point is we don't have WebCrypto support for these curves, as I mentioned. So we still need to decrypt it in the browser memory. And if you have a malicious plugin, it can still copy out the raw key information. It can maybe hold, an attacker can maybe hold this private key. And if you then get a lot of money transferred into this account, it can instantly transfer it out because it has a copy of the private key, right? So we haven't really solved the problem just yet. So how do we try to solve this? And this is then sort of the meat of the proposal, and where it's very welcome to try to break it down and help improve it. What we suggest is that what's not there cannot be stolen. And specifically in the case of Filecoin, the most efficient way to achieve that is by using aggregate signatures for the actual account with which you would act on the chain. So if we work with aggregated signatures, then the single key that Alice stores on her file system by itself doesn't have any meaning, right? Because it's just one of the two signatures. It's not a valid transaction for anything that Filecoin recognizes. And so a brief word on like BLS magic. Specifically what interests us here, there's more magic tricks available, but in a very simplified way, but in a real sense, if you add one public key from Alice to a public key from Bob, then you get a new public key, which it looks just like any of the public keys. There's a little asterisk here because you're doing this addition in a highly non-trivial space of points on the elliptic curve. So that's one thing. And it's also not a linear addition because there's an attack vector. If you just simply do a linear addition of the keys, you have a rogue attack, rogue key attack, same as with Schnorr aggregation. So hence the asterisk, but for ease of conversation, you can just add up public keys and generate a new one. And then a valid signature for this new public key is the addition with same notes of the signatures of the two separate keys. And so as a result, the private key itself never existed. For Filecoin, this is very efficient because it supports BLS 381. For Ethereum, we have to wait until the Berlin hard fork for this curve support to come around. The existing curves, Alt BN 128, you could do key pairing with this and signature aggregation, but there are reports that this has actually below 100 bit security. So for example, if you'd want to implement this on Ethereum right now, it would be better to write an explicit contract or take a multi-sig contract with a 2 of 2 requirement of signatures. You'd basically achieve the same thing, right? It's just a logical operation. But if you have BLS support, it's super efficient because it just looks like a normal signature. There's also no setup phase to this signature aggregation. So that makes it very tempting. That's all great, but actually, have we solved anything? Because who is that second key, and when will it sign? So imagine that we would say like, oh, we put this second key on a mobile phone of the user or on a desktop app of the user, and now when we want to do a transaction, he needs to, or she needs to confirm on their second device. That sounds good, but then actually MetaMask or Wallet Connect already have the same user flow and the same security in a much simpler design, right? Just put the original SCCP key in the secure device and don't have a key in the browser, and you get the same end result. So I've carried you all here for no apparently good reason, except that if you're working in a browser, you're dealing with HTTP requests, and you need to get a signed transaction to a peer-to-peer network, and it doesn't make a lot of sense to try directly connecting to the peer-to-peer network from the browser window. So you always have a service in the middle. Infura or MetaMask also needs to push signed transactions, or there's more advanced like meta transaction relayers, etc. So we can actually do secure signing in the browser with UCANs, because we can keep delegating permission to sign specific or take specific actions. We have the root authorization on Boris's DID key, which he delegated for a specific session, say max 10 minutes, next 10 minutes, or max amount of spending to the application, which then in turn can further delegate and attenuate the rights to the interface service, right? The one you would do an HTTP request, send raw transaction, send raw signed transaction to. But in this case, you're going to ask it to sign your transaction with its key as well. And it will only do that if you present a valid UCAN to do this. Why? Because those UCANs we actually can protect with WebCrypto. Those private keys are shielded from the JavaScript code. So you cannot just now lift the private key out of the browser environment and then outside of the browser environment sign another valid UCAN for a new transaction that would permit it. In particular, you're also constrained by whatever the initial authorization for this session was. And so because you can only further attenuate, you can't extend the rights that were specified there. Of course, you introduce new problems. What if because you're now tightly coupled to this cosigner service? In practice, like dApps run to Infura, and then if Infura would go down, the dApp effectively is also out of service, but the principle is still real, right? There's a real concern here that you could be censored, and that or that the cosigner Fission is forced to refuse signing your transactions, and you'd be locked out of your account. So what you want to do here is actually never initialize an account with the 2 of 2 BLS key, but always create a 1 of n multi-sig account, and then put one 2 of 2 BLS key as an owner into that. And you can even go beyond and say if there's multiple independent cosigners, there's hardly any overhead to generating multiple BLS pairs here. So if there's independent cosigners, you can always initiate your account with multiple parallel trajectories to reach Filecoin. If that's not enough, as an advanced user, you could also just say, I have a Ledger hardware wallet, so I'm going to put this public key also as 1 of n public keys in the multisig. then it becomes sort of a master key or recovery key. Even if you lose UNFS, you still have access to your accounts on Filecoin because you have this ledger device that you can go to if for whatever reason the browser interface doesn't work. And so I've already, and the other point is, like, I've already touched on this a little bit. If we could steal the private key from the browser environment, we can surely also steal the UCANs from the browser environment, but we can't do anything specific with those UCANs because we don't have the signing key to further delegate actions with them. So the only attack that exists is where, as an attacker in the live session in the browser, you would ask the WebCrypto API to sign a specific UCAN for a specific transaction that you've signed. So you contain the attack to the active browser window and to the permissions that have been granted for that session.
Which is functionally equivalent to if you're literally in your desktop operating system and you get a pop-up that says, enter your admin password. Right.
Yeah. And so the root of your security really sits on that original DID Boris key, right? If you're paranoid about that, you could move that out of the browser, but we do argue that for a vast amount of use cases, this authorization page, which by itself is also served over IPFS content as a static page content address, is highly secure and worth the trade-off. There's a slightly more confusing diagram for this on Whimsical, but we'll post a blog post where you can go into this. But it sort of has the same structure as before, but just tries to confuse things with cryptic notations. But we'll update it. Yeah, that's roughly the layout. So it's Thanksgiving. Thank you all for listening. If there's any questions, definitely want to continue the conversation. And thank you to the Fission team for the opportunity, because it's a super interesting problem to try to solve. We think that this is a good path forward, but obviously this is a design phase. So any criticism is very welcome before we try to build this. And also during and after we try to build this.
Yeah, and
very much welcome.
Probably not mentioned here, but or I didn't mention at the beginning, all this stuff is open source. We have a couple of bits and pieces of the platform that we ended up putting under a non-commercial license. But the vast majority of these things that are like components and libraries tend to be under MIT or Apache. And the entire Fission platform, what we really see, and we are having some early discussions with, you know, we're running all this, we can integrate it vertically, we can automate DNS and do a bunch of things like that. But we really see ourselves federating, and that's why we're built on top of things like DIDs. So someone could build the same thing. Instead of handing out DNS subdomains, they could hand out ENS subdomains. I had one discussion with someone who was like, could this be used for, with James and I were on a call, could this be used for IoT? And in fact, handing every single IoT device a UCAN and passing around their data end-to-end encrypted, and using the Fission platform to actually manage hundreds or thousands of IoT devices is like, yep, that could map to that as well. So just to give that perspective, you know, we're going to run this. There's a lot of these components of things that we're not going to do. We're not heavily in the crypto direction, other than we want to get involved early with the Filecoin community. We were involved early with Ethereum, which has improved and done a bunch of things. And it's early enough in Filecoin that some of these things around accounts and wallets and making stuff work in browser. So there is no effectively easy way to build apps in browser right now with Filecoin without making some compromises somewhere along the chain. And so this was our goal, to see if we could use WinFS and UCAN as building blocks to get there. And theoretically, this should map to other systems that also have private keys. So we've got Ivan and Chris from, we're doing work with SSB that ideally want to get private keys in browsers, and then lots of Ethereum folks and as well. I know that's a lot and super intense. And probably for a lot of you, going through this with the written version is going to be helpful. And we will make the recording available as well, obviously. Any thoughts and comments on this?
I would have just one in regard of that comment, what can be there cannot be stolen, and in regard of private keys. Actually, that was also one of my realizations the more I was digging into the IDs and also reading more about UCAN and working on our stuff on the planetary end, that in fact, private keys should be pushed the most to the edge, and chaining permissions or authorizations is actually very reasonable path to go. So maybe in other words, like having private keys only for only on the fringes is like seems really cool and really reasonable. I'm saying that also in comparison to many other things and white papers I saw about secure exchange of private keys or moving private keys from one device to another and so on. And all of those seem overly complicated or insecure, like plainly. I think Ben was also mentioning that earlier too. So that's kind of my clumsy way of validating this approach. It looks really nice and promising in there.
And Chris has been working on a couple of things around verified credentials that we had an earlier discussion around. Everybody who's on the calendar invite, I know Carson asked about this. We'll post about this on all of our channels, but I'll do an email out to everyone and also link to some of the previous work we did in what we're looking at with verifiable credentials. So verifiable credentials is one more piece of sort of proving things that are then linked to some of these UCAN things that should be useful for going between systems. So some of the key-based like stuff like, yes, this key has control over this Twitter account. And so if you're moving between networks, you don't constantly have to re-auth those things. You can be like, you know, please look up all the people who claim to be B-Man.
Yeah, so, and going even further, you can tap into the whole area of distributed trust, like trust networks, and even maybe further some sort of trust marketplaces. So that's actually what I would like to elaborate at some point, maybe in the following weeks. That's also really cool thing to talk about.
A Christmas present for us all.
Yeah.
Carson, I know this is a lot on the security side, and I just wanted to call out that, like, very much we see this tying into, you know, Powergate and some of the stuff that you guys have built. Like, we're not duplicating any of that stuff. We're just bootstrapping all the way to, like, here's a secure key. We've also made the line in the sand for this demo. We're essentially going to assume that people need to come with their own Filecoin account. We're not going to go down the path of like us tackling creating Filecoin accounts in the browser. You know, there's a demo web wallet with that, but we're like that's right away. We're like, no, we're not going to tackle that part.
We actually have a kind of sidecar thing to Powergate that you can authenticate to using the IDs. So that should be able to just like plug into the system.
Amazing. If you can, do you have a link to something about that?
Yeah, I can dig that up.
That's great. Yeah, I mean, I think.
Yeah, thanks, Joel.
What we're really seeing with the IDs is they're pretty nascent in the sense that, like, they don't automatically interoperate. other than being of type DID key. So we're really at the point now of, so Chris with Planetary Social and SSB, the query team who's doing some with IPFS, looking for other people who are using DID key schemes and then seeing how we can build interoperability on top of that. Awesome.
I have a question, just kind of like sorting out my mental model of what you showed there. So you because you can't have attenuations on a key that you're sharing, you're splitting it up into two BLS keys, and you're entrusting the attenuation to the cosigner. Is that like a cosigner is just a service that's trusted to enforce its limits?
Yeah, so the security really, like, as a sort of am I muted? No.
No, I hear you.
The security, it's a trusted cosigner. So obvious, like if he does or it doesn't follow like the UCAN valid UCAN certificates, yeah, then that is obviously a problem. So the assumptions are that the cosigner service itself is not attacked or attackable, so you don't have access to that private key, and that it only follows valid UCANs. And as such, if you would just steal the private key out of the browser, you could sign a transaction with it or a message with it. But now it knows that it cannot sign this because you cannot present a valid UCAN for the specific transaction. So correct. So the cosigner and the authorization page are actually sort of the bridging pillars upon which the security relies.
Okay, then I have kind of two follow-ups then. One is, so there's a claim made kind of early, and Wallet Connect and MetaMask, provide an admittedly somewhat interrupted experience that this would somehow avoid. But there is an active delegation happening right here at the top of the funnel here, right? You're delegating some signing key to the app and some kind of attenuated key to the cosigner. So how do you imagine the user experience of that delegation happening? Like, is it avoiding a user interaction, or how's that happening?
No, so I think that the interesting question as we sort of explore this space going forward is how do you balance the user permission with the user experience? And it's always going to be application dependent and context dependent. The point I wanted to bring across for the current and Ethereum being sort of the most familiar system or most used, at least for me, is where you do need to get for every contract interaction a new signed permission from MetaMask or Wallet Connect, right? And so that might be okay for DeFi interactions. But if you want to do small, low value transactions, it might be more interesting to say, hey, if in the next 10 minutes, if I'm not spending more than $10 worth of money, like whatever I'm signing, it's okay. And you have that permission asked once, you formulate that in UCAN, and now the cosigner can see that it's not violating these original permissions that were granted when it signs those transactions in the middle. And in that way, we constrain the application. Okay. That was the idea.
Cool. That makes sense. So then just one last question, I think, which is, so if then to contrast how this could be built, let's say in a Wallet Connect or MetaMask scenario where a user has a single signer, because I could imagine something that enforces logic very similar to the cosigner just in the wallet. And so why doesn't an application just, it's got basically an access control list, but it knows how to read UCANs and enforce their attenuations. I guess, and I'll try to beat you to the punch. I guess the benefit is the application can submit these transactions with the user being offline, So you have a kind of a cosigner that can be persistent and kind of less trusted than the wallet itself. Is that one of the benefits, or what other benefits do you see to that architecture?
So the only real reason here why it says like Fission cosigner is just because it's an easy place for us to default to as we're building this out. But in principle, like it is a bit of a trusted party. So I mean, I hadn't even properly thought about this, but you could build this into, you could make Wallet Connect the cosigner, or MetaMask the cosigner, right? Or any other app that would integrate with it. The only thing it needs to get is behind the scenes the UCAN to see whether this is valid or not. And then indeed, you don't need to pop up Wallet Connect or MetaMask to do the signatures. And you could only do that if there was a request that violates the permissions it was given, for example, to one user at that point. So this cosigner could be anywhere. Yeah.
So what we're sprinting towards is the end-to-end experience in web where the user isn't adding anything else, right? There's these layers of whether it's Ledger or Wallet Connect or MetaMask that can plug into this. This is what can we stand up so that from the perspective of someone rolling up to a browser, they don't have to pre-set up or do anything else, right? We definitely think, you know, some of the discussions we've had with the Planetary Social team, they've got a native mobile app. Native mobile app gets you all sorts of interesting things that we think is a really great user experience with QR codes, and like a lot of these patterns are becoming more and more common. You know, our goal was like, let's bootstrap from the end-to-end web interface that we're unblocked from deploying.
Yeah, and maybe to follow up a bit more on this cosigner idea, this is what I imagine as space for trust marketplace, because this cosigner, given easy means to set it up, can be actually any authority, or even maybe your trusted friend or someone else, pretty much anyone with the server that runs specific API that can sign stuff for you or act in your name, either by issuing transactions or further delegating the credentials.
Right. So actually, like Argent does a very interesting model here where they combine in this guardian concept both recovery and also asserting that certain transactions may be exceeding expected limitations and asking for extra confirmation before signing off on it, right? So there are some very like really interesting UX experiences already built out that we can try to learn from here as well, for sure.
Yeah,
okay, good.
I was just gonna, so Joel's like, you know, when can we get better curves in the WebCrypto API? So, I mean, the short answer is no. And depending on how you think about it, Firefox / iOS are the laggards here. Chrome supports a couple of other ones, but we kind of are supporting things very, very broadly. And so we're sticking to stuff that like just works, including on mobile. There's a bunch of other stuff. Brooks always hates it when I bring up because it's not possible today, but WebAuthn is this other API where you could start using secure keys, NFC keys, but it's completely disconnected from the WebCrypto. So like if we had those two worlds connecting, you could do two-factor directly in browser and use biometrics in devices that you have, but it's yet another different thing that's not actually connected. So I think if more people use it and we start seeing use cases for it, then we can talk to browser vendors. But as we know, that's a multi-year thing. That's totally the kind of thing that we would love to get people going on. We do see a lot of this being not a crypto standards effort, but a web standards effort that actually gets us into W3C. So DIDs are in the W3C, verified credentials are in the W3C. So, you know, baby steps.
There's a small tangent here, as you sort of suggested. Like, would browsers not just natively accept these curves or implement these curves? Obviously, that would be great, but it's not like the holy grail that you'd expect, I would actually argue. For one, because I've actually tried to build this, and so that's a separate story. Because if you imagine now, like, if for every, you'd want the key to be not exportable. So if you would open the same app in a new browser window, you now need to go to the chain and confirm with a transaction that this other key in this other browser window is also a valid key for your contract to sign things. So you'd have, for each browser page that you'd open, you'd have to go and like send transactions to put the key into the ACL of the chain, and then also expire the key again, which you can do with logic in Ethereum, but not so easily in Filecoin, I think. So it's actually not, it would be great to have non-exportable keys for more advanced curves. Like, you definitely redesign some parts here, but it doesn't solve everything, because it's just not efficient to go update every browser page on Filecoin or Ethereum about this new key.
Dan, you had another question or comment.
Yeah, kind of on a totally different thing, just coming to your kind of key derivation thing. You know, I'm coming from the world of like seed phrases and stuff. And we've been looking at, you know, things kind of similar, like app keys or you know, some app specific delegated keys. So I'm kind of just curious, like generation and backup. I saw the keys are stored in the file system and encrypted in the, sorry, I'm still learning some of your a web native file system. So is that basically the backup is just the access to the IPFS document, or are you using a deterministic generation algorithm or anything like that? Or
the thinking right now would be just randomly generated and backed up to the file system. Yeah.
Cool.
Yeah. I mean,
Okay.
we can, so why not?
Yeah. So the harder part here is because we're piggybacking on UCANs to do the auth, and those are non-exportable. So how do we back up that root key? And so Ben and I put some time into that, but it's not fully baked yet, because if you puddle your devices, or you drop your phone and your laptop and everything in the lake, how do you recover that, right? And we're non-custodial, so what does that look like? So mainly to say that we're finding that to be the more challenging piece. We've looked at seed phrases and paper wallets and all of that, and probably the simplest solution, at least to start with, is giving people essentially something that looks like backup codes with a Shamir share encrypted and with multiple different codes, and make them one-time use on a server. But that's sort of as far as we've gotten. It's really still not fully baked.
We'll share our, like, again, like, this is us running a service, and Dan, you know what this is like, right? We'll share all these plans, and we again, the mental model is essentially iCloud, right? Additional devices, you put in a key. If you log in a new device, you get a little pop-up on your other devices that are logged in, and we lean on IPFS, PubSub, and a few other pieces of the stack that we have. And then, but we can say for both developers and for users, we don't have the keys, your stuff is encrypted, which means if you puddle, you will lose all your stuff. And so the end user is only on a single mobile device is the most at risk. From our research, developers, we put a key on a developer machine as part of CLI setup. And you usually don't puddle your home desktop. And from looking at, it's essentially the same pattern as a GitHub key. And the people that we've talked to, it's like, we literally ask, we're like, do you change your GitHub key? And they're like, yeah, when I get a new machine. And I'm like, do you have trouble doing that? They're like, no, I just Google how to do it and follow the instructions again. So that's pretty interesting to see that in the wild. So we at the same time, for those mobile only users, which is lots of users, we can't just say, oops, you lost all your encrypted files and you can never get them back. So right now that'll look like, as Brooke said, we will run those things as a service so that you can do that. And possibly if we get essentially have an opt-out of that recovery. So if advanced users are like, no, I want to manage my own keys, we're like, cool. If you puddle, your encrypted stuff is gone. We can reset your account in Fission, so you get to keep the username Dan Finley, and we can keep even your public files because they're public and they're visible on IPFS. But we're going to have to blow away your encrypted one, and them's the breaks. So that's how we're thinking about it right now. And we'll share all these designs because, again, we have to document this for both how we build it. It'll be open source and you can look at it. And we have to document it for users and what the user expectation is of how this stuff works. Amazing. Have a fun Thanksgiving, Zoom. Thanks, Dan.
Take care.
Look at that, Ben. You got it done in an hour with questions and discussion. Easy. The top of my brain is smoking, but that's fine. Like, no problem.
Well, it had pretty pictures, I think, colorful.
Yeah, Carson. So, I think really what we want to see next is if we can have the reason that we aimed all the way for here is that we want to give the Filecoin community the ability to build Filecoin connected apps with as few intermediate, just trust this person in the middle kind of thing. And that was our goal for aiming it, because of course it's the same stack that we've been aiming for, right? So the backup app. So what's next, just to let everyone know. So research, it'll be shared. I'll send out an email. It'll all be on the forum. For those of you in the Filecoin community, we're in the Filecoin shared Slack as well. Happy to take questions over basically any format. Ben's got some long form prose written out about this. We've got some diagrams. He showed it briefly. Those are zoomable, so you can trace through them and get PDF versions of this. We'll have links to UCAN and other things like that. So the white paper version, if you want to dig into the stuff behind this. Now we'll be moving on kind of in parallel of essentially doing the web native Filecoin plugin that implements this at the library layer, as well as starting to build out the basics of an end-to-end app, where the second phase will be the library and the basic scaffolding of showing that it's working in browser. And the third phase is, okay, here's an entire app, very basic around, doing Filecoin backups. And we've had some feedback there already that there's some tricky things in there of how we're gonna do it. But we're ideally gonna build this app in either Svelte, which Ben's now fallen in love with, or React, and have it as sort of both a proof of concept, but also like, here's yeah, I know. that's from Samuel as well, who's a big Svelte fan. And then that'll be there as an open source app that other people can see how IPFS powered and Filecoin powered apps can be built, and people can use that to build any sort of Filecoin interactions.
Nice, Carson. Yeah, I'm new to front-end development, so I'm just super happy that something like this exists, where I had an idea that I knew what was going on instead with React, where I still don't.
Yes, if anybody has some cycles and would like to do some product and design work on Svelte, ping me. So, our kind of goal with these Filecoin grants is just to turn it into people, so that people can turn stuff into open source code. I don't know if I have something public about that yet. Samuel, if you want to do some app and product design stuff, that might be really great. Ben already, and I've dug into web native, so that could be an opportunity to work more together. Oh yeah, while I'm at it, does anyone know any 11D developers / designers? That's the other one that I'm a fan of. I'll post about it in the forum.
I didn't even hear it.
Does anyone else have anything else they want to like share, promote, talk about? I'll actually, you know what? I will stop recording.